Hess's law states that the overall change in enthalpy for a chemical reaction is equal to the sum of the enthalpy changes for each step. And this is independent of the path taken, so it doesn't matter what set of reactions you use. If you add up those reactions and they equal the reaction that you're trying to find, you can also sum the enthalpies to find the enthalpy change for the reaction. As an example, let's say we're trying to find the change in enthalpy for the reaction of carbon with hydrogen gas to form C2H2, which is acetylene. We can calculate the change in enthalpy for the formation of acetylene using these three reactions below. Our approach will involve looking at these three reactions and comparing them to the original reaction to see if we need to change anything. For example, if we look at reaction 1, there's 1 mole of acetylene on the left side of the equation. And if we compare that to the original reaction, there's 1 mole of acetylene on the right side of the equation. So we need to reverse equation 1 to make it look more like our original reaction. To save time, I've gone ahead and reversed equation 1, so you can see I did that down here. Looking at the original equation for equation 1, here were the products, and now we've made those products the reactants, and what were the reactants over here for equation 1 have now become the products. The change in enthalpy for equation 1 is negative 1,299.6 kilojoules per mole of reaction. Kilojoules per mole of reaction just means how the reaction is written in the balanced equation. And since we've reversed equation 1, we also need to reverse the sign for delta H. So instead of this being a negative, we're going to go ahead and change this into a positive. And also, let's go ahead and cross out the first equation so we don't get confused. Next, we look at equation 2 and we compare it to our original. For equation 2, there's 1 mole of solid carbon on the left side, and looking at our original reaction, there's 2 moles of carbon on the left side. So to get equation 2 to look like our original equation, we need to multiply everything through by a factor of 2. So we're going to multiply everything in equation 2 by a factor of 2. To save some time, I've gone ahead and written out what we would get. We would get 2 carbons plus 2 O2s goes to 2 CO2. The change in the enthalpy for the formation of 1 mole of CO2 was negative 393.5 kilojoules per mole of reaction. But now we're forming 2 moles of CO2. And since we multiplied the equation through by a factor of 2, we also need to multiply the change in enthalpy by a factor of 2 as well. And also, let's go ahead and cross out this first version here, because now we're forming 2 moles of CO2. Next, we look at equation 3, and we can see there's 1 mole of hydrogen gas on the left side of the equation, which matches the original reaction, which also has 1 mole of hydrogen gas on the left side. So we don't need to do anything to equation 3, and since we're not doing anything to the equation, we're also not going to do anything to the change in the enthalpy. So it's going to stay negative 285.8 kilojoules per mole of reaction. Next, we add up all of our reactants and products. So we have 2CO2 plus H2O plus 2C plus 2O2 plus H2 plus 1/2 O2. So those are all written down here for our reactants. And then for the products, let me just change colors here. We have C2H2 plus 5O2 plus 2CO2 plus H2O. And so those are written over here for the products. Next, we see what we can cancel out. There's 2 CO2s on the left side, and there's 2 CO2s on the right side, so those cancel out. There's 1 water on the left and 1 water on the right. And there's 2 O2s plus 1/2 O2, which is 2.5 O2s, or 5/2 O2s. So the oxygens cancel out on both sides as well. And we can see we're left with 2 carbons plus 1 hydrogen goes to form 1 C2H2, which is the same as our original equation. Since we were able to add up our equations and get the overall equation, according to Hess's law, we should also be able to add the changes in enthalpies for these steps to get the change in the enthalpy for the overall reaction. If we look at the changes in enthalpy for the individual steps, we had positive 1299.6 for the first equation, and so that's up here. For the second equation, we had negative 393.5 times 2, which is negative 787. And for our third equation, we had negative 285.8, so that's negative 285.8. When we add everything together, we get positive 226.8 kilojoules per mole of reaction. So for the formation of 1 mole of acetylene from 2 moles of carbon and 1 mole of hydrogen, the change in enthalpy for this reaction is equal to positive 226.8 kilojoules per mole of reaction.